Okay, we're going to talk about another type of problem, which is how to calculate partial derivatives from a table. So let me give an example of this kind of problem. Like if we have g of u and v is f of x, y, we're treating x and y as functions of u and v of this form, like e of u plus sine of v, e to the u plus cosine of v, then the problem is to find the partial derivative of g with respect to u at 0, 0, and the same thing with v. So by 0, 0, we mean u, v, not x, y. That's the point. Because 0, 0 goes into g, not f. Okay? So I hope that's notation is not too confusing. So, and they're giving you some data here because we don't know much about f. So we're using this table which has 3 rows and 4 columns of interest. And basically all of the quantities possible not involving u's and b's will be given to us. So for example, there'll be an 8, there'll be a 6, 5, 2. I'm just using example numbers here. 6, 8, 4, 0. And they'll be evaluated at these various points. So the issue that I see is there's actually too much data. So don't get freaked out if you're not using everything. Too much data, most is useless. Okay, so I'm going to circle the only data that you need. The only data you need is these 2 numbers right here. So only use the red data. So why am I only using these? So why not fx at 0, 0? Because 0, 0 goes into g, not f. So fx at 0, 0 is irrelevant. It's just extra data they're trying to use to trick you. So really, now that we're given these numbers, how do we get the g derivatives? So it's by the chain rule. So we're going to use the 2D chain rule to get g sub u, g sub v from f sub x, f sub y. So somehow the chain rule will take our function of x and y, it'll give us partial derivatives in u and g. Okay? So how do you do the chain rule? Let me just recall the 1D chain rule, which is that if you have g of u equals f of x, and x is a function of u, then ddu of g is df dx times dx du. So how do you summarize this? It is the derivative of f in its correct variable times a scaling factor. And the scaling which causes cancellation. Okay? So let me just unpack what I mean here. So f, if I take df, what do I put here? The only thing I can put here is x, because f is a function of x. Okay? So I put df dx here. And now what do I put here? The only thing I can put here is dx du. Why? Because we need cancellation. So the cancellation I'm talking about is the x's will cancel. Okay? So this will give you that du on the bottom that we want. Okay? That's how you do the chain rule. So how would I do the chain rule for dg du? Well, I would do the exact same stuff. I would put df dx's. I could put a df dy, because these are the things that f is a function of. So now I just need cancellation factors. So really what I want is a dx on top, remember, because this will cancel. And then I will put du on the bottom, because that is what is on the left-hand side. Okay? Now I just do the exact same thing. What do I put here? I put a y here to cancel, and then I put a u here so that it matches the left-hand side. So let me just rewrite that a little more compactly. F sub x times x sub u plus f sub y times y sub u. I'm again using lazy notation, because when you write this stuff over and over again, it gets kind of time consuming. So let's just write out what dg dv is. I will again write out df dx and df dy. And I will put my scaling factors of dx, d. Well, let's just come back to that. Surely I need cancellation, so dy d something. And now, in order to match that v, I will put a v here, and I will put a v here. That's it. That's all there is to this. So let me just write lazy notation. fxx v plus fy y v. Okay? That is the 2D chain rule. Okay, so we're going to use the and to summarize, it converts f sub x to g sub u, just like in 1D. Okay? So let's apply it to our example, where we had g of u v equals f of e to the u plus sine of v, e to the u plus cosine of v. So remember this is our x and this is our y. So let's do it. G sub u is f sub x, f sub y, and then we have our x sub u, y sub u, in order to have cancellation. So all we need to do is just compute x of u and x of v. So compute xu, xv, yu, yv. This is a crucial step we need to do. So x of u, well, it's just that e to the u, right? And then x of v, it's just cosine v. And yu is just e to the u, and yv is just minus sine v. So we now just plug them in. So f sub x times e to the u plus f sub y times e to the u. Okay? And let's just do the same thing with gv. gv is f sub x. There's also going to be an f sub y, because that's the stuff that f is a function of. And in order to have cancellation, we need x sub v times y sub v. So now we just plug in, again, what we computed. So now we have f sub x times cosine of v plus f sub y times minus sine of v. Okay, so this gives us what we want, but they're functions, right? So now evaluate at 0, 0. Remember, this is u and this is v. This is not x and y. So g sub u will then be equal to f sub x times e to the 0 plus f sub y times e to the 0. So that's just fx plus fy. So similarly, gv will be equal to f sub x times cosine of 0 plus f sub y times minus sine of 0. So that's 0, right? So then we just get f sub x. And these are at x of 0, y is 0. So u equals 0, v equals 0, and u equals 0, v equals 0. This is not the same thing, not the same thing as f sub x at 0, 0. Do not get this confused. No, bad. Okay? Why? Because 0, 0 is uv, In fact, what is x of 0? X of 0, 0 is e to the u plus sine of v at 0, 0. So this is 1. Similarly, y of 0, 0 is e to the u plus cosine of v at 0, 0. So this is equal to 1 plus 1, so it's 2. So actually, these things are evaluated at 1, 2, x, y. You can put these x, y's above the ordered pair if that's helpful. Okay, so to summarize, GU is fx plus fy evaluated at 1, 2, and this is x, y. And GV is fx evaluated at 1, 2, this is x, this is y. So now we just use the table to get numbers. So let's go back to the table. Our table, we want f of x, x, y. So actually you can see why these were utterly irrelevant. It's just too much data because we don't care about fg, we care about the derivatives. So now we just go to the right row. Remember, this is the uv. And this was what we computed for the xy. So I just want those last two numbers, 4, 0. So if we remember 4, 0, this was our fx, this was our fy, so let's plug it in. 4 plus 0 equals 4, and 4. So therefore, GU at 0, 0, this is our u, this is our v, this is just 4. GV at 0, 0, this is our u, this is our v, this is 4. And that's all there is to it. So I would say just do not get confused between u, v, and x, y. And you should just be able to crank out these numbers. Okay, thanks for watching.